All right, this rational expression right here, we're going to be breaking into what's known as partial fractions. Whenever you're breaking one of these into partial fractions, it is important to know how to factor this denominator. Okay? Now, when you're factoring, you're going to have a 2x here, you're going to have an x here. We have to figure out what numbers are going to go into these slots. Now, the only numbers you can use are the factors of 2. So you can only use a 2 or a 1. So either we're going to put a 2 here and a 1 here, or we're going to put a 2 here and a 1 right there. Okay? Now, what do those have to multiply together? They have to equal a negative 2 when multiplied together, but we need to somehow get to a negative 3 here in the middle. 2x plus 1, x minus 2. Let's see if this works. If we do the FOIL method right here, and I do 2x times an x, that is 2x squared. 2x times a negative 2 is a negative 4x. 1 times an x is a positive 1x. And 1 times a negative 2 is a negative 2. So yes, those are the correct factors, because if you multiply them together, we get our original trinomial right here. Okay? So those are the correct factors. So here's what I'd like to do. Now that we know those are the correct factors, I want you guys to set this whole thing right here equal to a, which we're going to solve for a, over 2x plus 1 plus b over x minus 2. Now I'm going to scroll down here and I'm going to rewrite everything so you know exactly what I want you to write. Okay? In the numerator we have 11x minus 7. In the denominator we have our two factors, 2x plus 1 and x minus 2. And we're setting that equal to a value that we're searching for. We're gonna solve for this guy. We're going to put him over 2x plus 1 plus b over x minus 2. And we're going to also solve for b. So once you have this written down, I need you to break your paper into 2 columns. Just make 2 columns. One column I want you guys to write solve for a. Next column I want you guys to write solve for b. So go and get that all set, ready to go. Alright, so before we start, what we're going to do is I need to take this whole expression right here. I need to take this whole expression and multiply it by 2x plus 1 times x minus 2. Alright? So when I take this whole expression right here and multiply it by 2x plus 1 times x minus 2, let's think about what's eliminated. So once again, I'm taking this, multiplying it to every single expression. In this first part, what's going to end up being eliminated right here in the denominators? Both of them. 2x plus 1 and x minus 2 will cancel out both of those. So what are we simply left with? 11x minus 7. So I'm going to move over here. And I'm going to write 11x minus 7. That's going to be our first product. Okay? Then I know I'm going to have an a. I'm going to have an a. You slide over here. When I take this right here and I multiply it to a, what's going to end up canceling out? The 2x plus 1. So this 2x plus 1 will cancel out this 2x plus 1. What do we have left? We have an x minus 2. So here I'm going to write, I'm going to have an x minus 2 left, plus b, let's slide over. So if we take this right here and multiply it to the b, what's going to end up canceling out? The x minus 2. So what are we left with? 2x plus 1. So right here I'm going to write, we are left with a 2x plus 1. Okay? So right now, this right here is the product after we've multiplied everything times a 2x plus 1 and an x minus 2. Alright? So just to make it easier for y'all, I'm going to put solve for A. I'm going to put solve for B. I want you guys to have this equation right above where it says solve for A and solve for B. Okay? Now, when I said solve for A, what do we have to eliminate? We have to eliminate the B. Now, to eliminate the B, right here, what do I need to make this expression equal to? I need to set this equal to, set it equal to 0. So here's how you set it equal to 0. 2x plus 1 equals 0. We're going to solve for x, and x equals a negative 1 half. Now watch what happens when I plug in. If I plug in right here, if I plug in a negative 1 half, 2 times a negative half is a negative 1. What's negative 1 plus 1? 0. And now we don't have any b's, do we? So where are we going to plug in this negative 1 half? We're going to plug it in here, we're going to plug it in here, and we're going to plug it in here, knowing that it's going to cancel out all of our b's. So what I'm going to do right now is I'm going to plug it in. So right here I'm going to say 11. By the way, x is going to equal a negative half. That's what you're going to plug in. Right here. Plug in x, where it's equal to a negative half. So 11 minus a half is going to go in the parentheses, minus 7 equals a times negative half minus 2. So right now I want you to pay close attention. We're just taking this negative half, we're plugging it in here, and we're plugging it in right there. Now why didn't I worry about the b? Because I knew if I plugged in a negative half, it canceled everything out. Alright? So now what we're going to do is we're going to solve for a. A negative half times an 11 is negative 11 over 2 minus 7 equals a times, now negative half minus 2 is negative 2.5, which is the same as negative 5 over 2. So just so you guys know, negative 2.5 is the same as negative 5 over 2. If you combine these right here, this is negative 5.5, that's minus 7, that's negative what? Negative 12.5, which is the same as negative 25 over 2, and that's equal to a times negative 5 over 2. So you guys have graphing calculators. So obviously you guys can just type that in and it'll spit out negative 12.5. All I've done is just changed it into an improper fraction. Okay? Doing it by hand, though, what I'm going to do to solve this is I'm going to multiply both sides by negative 2/5, which is the reciprocal. The reciprocal of negative 5 over 2 is negative 2 over 5. So notice what's going to happen to these. These are going to cancel out. What's going to happen to these negatives? They're going to turn to positives. What's going to happen to these 2's? They're going to cancel out. 25 divided by 5 is simply a 5. So 5 is equal to your capital A. Alright, 5 is equal to your capital A. Now this one is more difficult because what do we have to plug in? We had to plug in a negative half. It wasn't just a nice easy number to plug in. Correct. The other one, let me scroll up here. The other one's a lot easier because I'll do this one in red. Actually, purple. Alright? What number do I need to plug in to eliminate? I'm going to put it right here. Eliminate A. I need to plug in a 2. Plug in 2 for what? For all of your x's. So if I plug in a 2 right there, what's going to happen to all of my a's? They're going to be canceled out because 2 minus 2 is 0, and any number times 0 is 0. Okay? we're going to plug in a 2. So right now we have an 11. We're going to open up a parentheses. We're going to plug in a 2. We're going to minus a 7. We're going to say that's equal to B. Bless you. Now we have a 2. I'm going to open up another parentheses, plug in a 2, and add 1. So I want you guys to understand right now, this 2x plus 1, what have I plugged in for that x? I've plugged in a 2 right there, and I've plugged in a 2 right there. Notice I didn't write anything for a because we know that that's canceled out. All right, 11 times 2 is 22, minus 7. 2 times 2 is 4. 4 plus 1 is 5. Okay? What's 22 minus 7? 15. 15 equals 5 times b, and automatically we can see that b is equal to a 3 if you divide both sides by 5. Now, we solved for a, we solved for b. What I want you guys to understand is, well, how do we write our final answer? Let's look at our partial fractions. We're going to scroll over here. Does everybody see these partial fractions right here? We're going to use this to help plug in. What are we going to plug in for a? We're going to plug in a 5. We're going to plug in a 3. So right now, your final answer, everybody. Remember, the final answer for your partial fractions is 5 over 2x plus 1 plus 3 over x minus 2. Those are your partial fractions. And what if we added those together? What would they eventually equal if we did all that work, which we're not going to do? Eventually, we added those together, you would get 11x minus 7 over 2x plus 1 times x minus 2. Now, you don't have to put that as part of your answer. I just want you to understand that this plus this would get us back to our original question, which is that. Okay? So once again, your final answer is this right here.